Hello, welcome to my recorded classes. So, this recorded video we are discussing a topic from module 4, selected topics in graph theory, section number 4.4, trees and applications of trees. So, let's start the content here. Actually, this section from, as I told you, module number 4, selected topics in graph theory. It is section number 4.4, trees and applications of tree. It is section number 4 in this module. 4.1, 4.2, 3 and 5 already we discussed. So here we are going to 4.4, trees and applications of trees. Okay, so we will go to the content here. Before going to the content, you can see one simple example here. Okay, how we are defining a tree. Same like a natural example here. See, we have naturally one tree, we have one root here, and there are many branches are there. There are leaves, correct? So same like we have one root here in the tree. This is the mathematical representation or tree diagram here. There will be one tree and there is having some branches is there, and we have leaves also there, correct? It is representing like a graph here. Okay, so this is the simple way to understood the meaning of tree. Okay, now let's start the ideas here. So whatever we are discussing this section, the ideas we are telling first. Okay, briefly we are telling all the idea, what is the meaning. Then we will go to the exercise and we will do more questions in the exercise. Okay, so let me start the definition of tree here. A tree is a connected, okay, it should be connected graph, connected undirected graph with no simple circuits. This is the simple definition of a tree. A tree means it should be connected. Connected means what is the meaning? There is a path between every pair of vertices. Okay, that is the meaning connected. For example, I can give one example here. See, I am just drawing one tree here. There are some vertices I am highlighting here. Okay, for example, this tree. Okay, one example, this tree. What is the condition we are telling? A tree is a connected undirected graph. Okay, it should be connected. Connected means if you are taking any pair of vertices, for example, this one vertex, vertex number 1, and for example, this vertex, vertex number 3, for example, this is vertex 2, vertex 3, vertex number 4, vertex number 5. Now, if you are taking any pair of vertices, for example, vertex number 1 and vertex number 3, okay, there should have a path between these two. See, for example, we have a path V1 to V2 and V2 to V3. There should have a path in between these two vertices. So like that, if you are taking any pair of vertices, we will get one path connecting that two vertices, correct? That is the meaning of connected. Okay, for example, V1 and V5. What is the path connecting? V1 to V2 we can move, V2 to V5 we can move. That is there is a path there, correct? So tree means it is a connected undirected graph with no simple circuits, correct? With no simple circuits. Now, what is the meaning simple circuit? Okay, simple circuit means it is just a walk through that tree with no repeated vertices except the end vertices, and edges also cannot be repeated. Okay, that start and end with the same vertex. Okay, this is the meaning of the simple circuit. So simple circuit means what we need to care actually, we need to walk through a tree, okay, such that vertex cannot be repeated and edges cannot be repeated except the end vertex. End vertex can repeat. Okay, so like that there is no simple circuit. Simple circuit does not exist. For example, this graph, one graph is given here. So in this graph, for example, if I am traveling from the vertex number 1, correct? Vertex number 1, I am traveling number 2, then traveling number 3, then again come to the number 1 vertex. So starting vertex and ending vertex is same, number 1. And there is no repetition of the vertex and no repetition of edge. So this is a circuit actually, correct? Simple circuit. So we can write that simple circuit like this. 1, okay, first we started with one vertex, then we moved through E1 edge, then we reached 2, then 2 to E2, E2 to 3, E3 to 1. So we are getting a simple circuit. So same like this simple circuit should not be there in a tree. Okay, if there is a simple circuit, it is not a tree. Okay, so tree, it is free from a simple circuit. So tree means it is connected undirected graph with no simple circuit. Okay, you can see this graph. See here, there is no simple circuit in that graph, correct? There is no simple circuit in this graph. For example, if I am putting one edge here, then it is not a tree because there is a circuit there. For example, if you are starting from V2 and V3 and V5 and V2, we are reaching the same point, correct? So this is a circuit, simple circuit, correct? It should not be there in a tree, that one. So if there is a circuit, the simple circuit, that is not a tree. Okay, so this graph, if you are removing this edge, only we are getting a tree, correct? This is a tree, there is no simple circuit, it is connected also. So this is the meaning of tree. So a tree, what are the things cannot have? Simple circuit should not be there, correct? Multiple edges should not be there, loops should not be there. Multiple edge means we are studied before section. For example, there is the multiple edge, correct? There is multiple edge, more than one edge connecting with the two vertices. That is the meaning multiple edge. That should not be there. And loop should not be there. You know what is the meaning of loop? This loop should not be there, correct? So these two cannot have a tree. But what should be there in a tree must be connected. A tree should be connected and it should be a simple graph. Simple graph means it should not have loop and multiple edge. Okay, so this is the meaning of roughly meaning of a tree here. Hope you understood that one. Okay, so when we are getting a graph like this, only we are need to check, what we need to check, that the graph should be connected. That is the first point we need to check. And the second point, it should not have no simple circuit. Okay, it should not have a simple circuit. And also I told you multiple edge. Okay, multiple edge and loop should not be there, correct? Loop also should not be there. So that type of graphs we are calling tree. Okay, now let me go to some examples here. You can see some example. This is a tree, correct? The first example, it is representing a tree here. There is no loop there, there is no multiple edge, or it is connected, all the vertices are connected, and there is not simple circuit also. And this is also a tree, correct? There is no simple circuit, all are connected, correct? This is also a tree, example of tree. But this is not an example of tree, correct? Because this is not connected. For example, this vertex and this vertex, there is no path. There is no path. Okay, nobody can go from this vertex to this vertex. There is no path between these two vertices. That means that two graphs, that graph is not connected, correct? There are two branches, that graph, but it is not connected. So not connected means it is not a tree. Now this graph also not a tree. Okay, not a tree, because why it is not a tree? It is having a simple circuit, correct? Where is the circuit here? For example, starting from here, we are going like this, we are going like this, and we are reaching the same point, correct? There is a circuit, simple circuit is there. So that is not a tree actually. Now this one is also not a tree because it is a loop. Loop should not be there in a tree. And this is also not a tree because that graph having a simple circuit. For example, what is the circuit? Starting from here and going here, here and here, starting and ending same, correct? There is a simple circuit. So circuit means vertex cannot be repeated, edge cannot be repeated, starting and ending should be same. Okay, like that one walk, if you are getting, that is a simple circuit. So it should not have a simple circuit in a tree. Now what about this last graph? It is also not a tree because it is having a simple circuit. So from here, for example, from here if you are starting, if you are going like this, we can reach the same point, correct? So that is not a tree here. So these are the simple examples of tree. So tree, when we are checking, first we check connected or not, simple circuits coming or not, or loop or multiple edge like that coming or not, just check it. If all not there, it is a tree, correct? Connected should be, and no simple circuit, loop no, okay, and multiple edges no. Now what is the meaning of rooted tree? Okay, what is the meaning of rooted tree? Now we are defining. Now rooted tree means it is a tree which one vertex has been designated as a root. Okay, one vertex should be assigned as a root. and every edge is directed away from the root. Okay, so what is the meaning actually? See, for example, this last graph, you can see the last graph, correct? One of the vertex is assigned as a root. Root means all other edges directed from that vertex. Okay, this is starting from here, and all other going from that sub branch only, correct? So that is the meaning root vertex. In the beginning I shown to you in that tree what is the meaning of root, correct? The same idea. So rooted tree means a tree. Okay, a rooted tree means it is a tree. One vertex is assigned as a root, and every edge is directed away from that root. Okay, so this is the root vertex here, or this example, this is the root vertex A, because all other edges are going away from that root vertex. Now we can change unrooted tree into a rooted tree by choosing any vertex as a root. For example, this tree. See, this tree we can draw like see, this vertex I can take it as a root. Draw the tree as it is like this. See, I am drawing in different shape. So I am getting root from root A. I can get it one tree. So if there is no if we are getting one unrooted tree, we can make into a rooted tree by choosing any vertex as a root here. So this graph with root A I am drawing like this, and the same graph with the root C I am drawing like this one. See, starting with the C. Okay, yeah, the same graph we are drawing in different shape. That is the meaning of that one. Okay, now the third point, usually draw a rooted tree with its root in the top of the graph. Okay, usually rooted tree we are drawing, the root will be the top vertex we are taking as root. See, this is the root here, and this is the root here. Now the different choice of root produce different rooted tree. From this graph itself I drawn two trees here. With root A I drawn one graph, with root C I am drawing one graph. So different choice of the root produce different rooted trees are there. So I hope you understood what is the meaning of rooted tree. Nothing, just main one vertex we are assigning as a root. Okay, and every edges are directed away from that root. So that is the rooted tree. Okay, now we have some small ideas here, some definitions or some remarks are there. Trivial tree, what is the meaning of trivial tree? Trivial tree means a graph consists a single vertex. For example, one vertex only if you are doing, vertex 1. Okay, this tree we are calling a trivial tree. Okay, trivial tree or degenerate tree we are telling. Single vertex, that is the meaning trivial tree. Empty tree, second point, empty tree. What is the meaning empty tree? A tree does not have any vertex. It is empty, nothing is there. Okay, just a small idea that one. Empty tree means a tree that does not have any vertices. Okay, now this point is very important here. A tree with n vertices has n minus 1 edges. Okay, a tree with n vertices having n minus 1 edges should be there. That is the next point. That is very important point. For example, see, I am drawing one tree here. This is the root of the tree, correct? Rooted tree. For example, I am just drawing the branches of the tree. For example, like this. Okay. So you can see how many vertices are there. This is vertex 1, vertex number 2, vertex number 3, vertex number 4, and vertex number 5. Correct? So how many vertices are there? Number of vertices equal. Correct? Number of vertices n equal to, vertices number we are representing by small letter n equal to 5 vertices are there. Now how many number of edges? Correct? Number of edges, you can check that one, how many edges are there. How many edges are there? We can just assign. For example, this is edge number 1, this is edge number 2, this is edge number 3, this is edge number 4. So how many edges are there? Equal to 4. So always edge number will be just a subtraction of 1, minus 1 number of vertices. Number of vertices 5 means edge equal to 4. That means 5 minus 1. Okay, number of vertices minus 1. That is the number of edges. So that is the rule here it is telling. A tree with n vertices has n minus 1 edges. Okay, so number of vertices of a tree means n means how many edges will be there? N minus 1 edges will be there. Okay, so just to note that rule there. Now, any connected graph with n vertices and n minus 1 edges is a tree. Any graph, whenever we are doing any graph with n vertices and n minus 1 edges, always it should be a tree. Okay. Now, a tree is a connected, but if any edge is deleted from it, then the resulting graph is not connected. Okay. For example, here, see, this graph is connected, this tree is connected. Now, if you are removing any edge from here, for example, I am removed from edge, that graph is not connected. That is the meaning of that one. If any edge removed from a tree, it should not be connected. Now, any tree has more than one vertex has at least 2 vertices of degree 1. Any tree has more than one vertex has at least 2 vertex of degree 1. For example, this graph you can see. Okay, how many vertices of degree 1 here? See, this graph. This vertex degree 1, this vertex degree 1, this vertex degree 1, correct? So you can see this vertex is degree 2, correct? This vertex is degree 3 here. Now what is telling actually, any tree more than one vertex is there means at least 2 vertex of degree 1. Here you can see we are getting 3 vertex degree 1, correct? Our minimum 2 vertex degree should be 1 there. That is the point here it is telling. Now a graph is a tree if and only if there is a unique path between any 2 vertices. If you are taking any 2 vertex, you will get a unique path between that 2 vertex. For example, V4 and V1. Okay, what is the path between V4 and V1? V1 to V3 first we can travel, then V3 to V4 we can travel. There is a path we are getting. Like that, if you are taking any pair of vertex, you will get a unique path, one path from that vertex to another vertex. Okay, so that is the point here discussing. So out of this point careful, this highlighted point, a tree with n vertices has n minus 1 edges. Okay, now let me go to one example here. Okay, so whatever we discussed here just now, we will do one example here. Explain, example number 1, explain why graph with given specification do not exist. Okay, there is some specification is given. Okay, that graph do not exist. Why? What is the reason for that one? For example, a tree having 12 vertices and 15 edges doesn't exist. What is the reason? A tree 12 vertices and 15 edges doesn't exist. What is the reason for that one? That is the question here. How many vertices are there? 12. That means n equal to 12. Number of vertices equal to 12. Now just now we studied, if we have n vertices, how many edges will be there? N minus 1 edges, correct? So 12 vertices means how many edges it should be? Edges means n minus 1, 1 less, correct? So 12 minus 1. 12 minus 1 means how many? 11. 11 only possible. But here how many edges it is given in the question? 15 edge. It is not possible, correct? It should be 11 edge. So that means a tree with 12 vertices and 15 edges doesn't, we cannot draw the graph like that one. Okay, it's not possible. That specification does not exist. Okay, that is the idea here. So a tree with 12 vertices will have only 11 edge, not 15. Okay, it is not possible. Now what is the second question? You can see a tree with 5 vertices, total degree should be 10. Is it possible or not? That is the question. Okay, a tree, it should be a tree, okay, with how many vertices? 5 vertices. So number of vertices equal to 5. Okay, and total degree equal to 10. That means sum of degrees, okay, sum of the degree equal to 10 is not possible. Why? What is the reason? Okay, n means number of vertices, correct? Number of vertices equal to 5. Now why this is not possible? Because we are studied one rule in previous section, that is handshaking theorem, correct? What is handshaking theorem we are studied? Handshaking theorem means sum of the degrees of the vertices, correct, equal to 2 times number of edges, correct? Sum of the degrees of the vertices equal to 2 times number of edges, correct? Now here when we are doing this question, you can see in this question how many vertices are there? 5 vertices are there. Sum of the degree equal to how many? It is equal to 10. So we can check that one. See, equal to sum of the degree equal to 10. It is given in the question, equal to 2 times e, correct? So from here What is the value of E here? 10 divided by 2. We can divide both sides by 2. So 10 divided by 2. So E equal to how much? Equal to 5. Correct? That means how many number of edges? Number of edges equal to 5. Correct? Number of edges equal to 5. Is it possible number of edges 5? How many vertices we have? 5 vertices. It is a tree, correct? In a tree, 5 vertices means how many edges should be? Only 4. But here we are getting 5. It is not possible, correct? It is a contradiction. So that is why, like this specification, a tree not exist. Okay. So number of vertices 5 means n minus 1 edges should be, correct? N minus 1 edges means 5 minus 1 edges. That means 4 only possible, correct? But what answer we are getting here? 4 only possible. But what answer we got here? 5. It is wrong, correct? It is wrong. 5 is not possible. So this graph, a tree with this specification not exist, correct? So a tree with 5 vertices, only we have 4 edges. But from handshaking theorem, we are getting more than that one. 2 times number of edges means 8 will get it. 8 is not possible. Okay, it should not be that one. So the specification is wrong. So 2 ways you can answer this question. Either you can answer like this, okay, or you can answer like this one. Both are correct here. See, a tree with 5 vertices, how many edges will be there? 4 edges will be there. N minus 1, correct? N minus 1. 4 edges. So total degree of graph by handshaking theorem, how much we can write? 2 times number of edges, correct? Just now I wrote here 2 times E. So 2 times E means 2 times 4, that is 8. So a tree with 5 vertices would have total degree 8. 8 only possible, not 10, because 2 multiply E, 2 times number of edges means the total degree. Total degree 8 only possible, but not 10. Here in our question it is given 10. So it is not possible. Like this you can answer, or like this you can answer. Both are correct answer. Okay. Hope you understood that question. Now we will come to the main point now. Tree terminology. Okay. In tree there are some point we need to know. Okay. For better understanding of tree, we need to know this point. Tree terminology. What are the terminology? What is the meaning of root? Root vertex. Okay. What are the edges of a tree? What is the meaning parent vertex? What is the meaning child? Child. Okay. Vertex means what is the meaning? Siblings. What is the meaning? Internal vertex. What is the meaning? Terminal vertex. Terminal vertex, or we are telling leaf. What is the meaning? And 8th one, what is the level of a graph? Height of a graph. Ancestor and descendant, what is the meaning? And subtree, what is the meaning? These are the main idea we need to discuss here. Okay, so we will discuss one by one these 11 points. First we will go root. After that edge 1, 2, 3, 4 up to 11 points are there. We will discuss one by one. So first we will go to the root vertex. What is the meaning root vertex? Already we discussed that one. Root vertex. What is the root vertex? The starting vertex here, correct? All other edges are directed from that vertex only. So this is the root vertex, capital A, root vertex. Edges, you know what is the meaning edges? See, this is one edge. Many edges are there, correct? These are all edges. Now already we studied a tree with n vertices having how many edges? N minus 1 edges, correct? So number of vertices n means n minus 1 edges should be there in that graph. So I hope you understood what is the meaning root vertex, what is the meaning edge of a tree, correct? How we are calculating number of edges in a rooted tree. Now we will come to what is the meaning parent and what is the meaning child, correct? For example, see A, capital A. This is a root, correct? Root vertex. Now this vertex, there are 2 child, correct? Children are there. See, one C and another one is B. B is one child and C is another child. This B we are calling just left child, and this one C we are calling the right child. Okay, right child. So this one we have 2 children are there, A, B and C. Same like this one, for example E. When we are taking E, we have 2 children, I and J. Left child means I, right child means it is J. Now if we are taking the opposite sense, for example K vertex, what is the parent of K? G is the parent of K, correct? Now same like here, for example, what is the parent of the vertex D? D vertex parent means who is the parent? That is B, correct? Now D, E, F, D, E and F, that are the children of the vertex B. Okay, so I hope you understood what is the meaning parent and child. So you can assume like this one. Okay, this one is the parent, this one is the parent, and this one is the first child. Okay, child 1, and this is the next child, child number 2. Correct. So this one we are calling left child, and this is one we are calling right child. Correct. Two children are there. Okay, so here if you are drawing, this is another child. Okay, child number 3, like that we can take that one. So that is the parent vertex. Okay, main vertex. For example, this is the parent vertex. B and C are the children are there. Hope you understood the first 4 points: root vertex, edges, parent and child. Now I am going to the next point, that is siblings and internal vertex and internal vertex and terminal vertex. Okay, so first we will discuss siblings. What is the meaning siblings? Siblings means nothing but just like you see in the English meaning, children of the same parent, that is calling siblings. Children of the same parent. For example, you can see this G and H. Okay, they are having same parent. Correct. Who is the parent? C. Correct. So G and H are siblings. Okay, G and H are siblings. So siblings means children of the same parent. Okay, that is the meaning sibling. For example, I and J are siblings because their parents are same. E is the parent. Correct. Same like that we can take many from here. For example, if you are taking B, who is the sibling with B? C. Correct, because they are children of the same parent. Correct. So that is the meaning sibling. Now next point we need to discuss internal vertex or branch vertex. Internal vertex or branch vertex. Internal vertex means vertex that have children is calling internal vertex. A vertex that is having children are called the internal vertex, or a vertex of degree greater than 1. More than 1 means that is a internal vertex. For example, this one. This is root vertex. Correct. As well as it is a internal vertex because this vertex having children. See, 2 children are there, B and C. Correct. So any vertex that having children is calling internal vertex. For example, this is internal vertex because this vertex having children. Okay, this vertex is internal vertex because this is having children. Correct. This is internal vertex because this is having children. So what are the internal vertex in this tree? A is internal vertex, B is internal vertex, C is internal vertex, E and G also internal vertex. So any vertex that have children are calling the internal vertex, or you can check the degree of each vertex. If degree greater than 1 means that are all internal vertex. For example, this vertex, what is the degree? This one, there are 2 edges. Correct. So degree is 2. More than 1 means that is a internal vertex. Same here. See how, what is the degree here? 1, 2, 3 and 4. 4 is the degree. So that is an internal vertex. Same like that we can check in other vertices also. So I hope you understood. A vertex that have children is calling the internal vertex. Now let me come to the next point, terminal vertex. What is the meaning of terminal vertex or leaf? We are calling the leaf. Okay, initially I shown what is the meaning of leaf. So terminal vertex or leaf means a vertex is calling a leaf or terminal vertex if it has no children. No children means that is the leaf. For example, this one, this vertex, there is no children for that one. This vertex, there is no children. This one, no children. Correct. This one, there is no child. Here also there is no children. Here also there is no children. These vertices we are calling the terminal vertex. So terminal vertex means what will be the degree? Degree of that vertex only 1, because only one edge. Okay, incident with that vertex only 1. See here also only 1. Degree is 1. Degree 1. Degree 1. Correct. Degree 1. So any vertex degree 1 means we are calling the terminal vertex or leaf vertex, or we can say any vertex that not having child. Okay, that is calling the terminal vertex. Now 8th point we need to check is level of a vertex. Important point. What is the meaning level of a vertex? You can see the level of each vertex here. Always the root vertex. This is the root vertex. Root vertex level always we are taking level 0. Okay, level 0. Now this is level 1 because the length of the path between these two vertices is 1. Only one edge. Okay, if you are moving through one edge, you can reach this vertex. Correct. That is the length of the path is 1. That is the level 1. Okay. Now if you are moving through two edges, level 2. For example, here level 1, then I am moving another edge like this. So if you want to reach this vertex, you need to move through two edges. That means length of the path equal to 2. That means level 2 here. Okay. Now same like, for example, if I am started with the A, I want to reach K. What is the level of that vertex? You can calculate length of the path. See, this is one edge, this is second edge, this is third edge. So level of that vertex equal to 3 here. Hope you understood that one. So length of the path from the root to the vertex. Okay, that is calling the level of the vertex. Length of the path from the root vertex to the vertex whatever we are considering. This is the root vertex to whatever vertex we are taking up to that one. How much length of the path, that is calling the level of that vertex. Hope you understood that one. Correct? Now let me ask one question here. You can see A and H. What is the level A and H? Because A to C one edge, C to H another edge. So 2 level. Correct? Level 2 will be there. Hope you understood that one. Now we will go to the 9th one. Okay, you can see 9th point. Height of a rooted tree. What is the meaning of height of a rooted tree? Height of a rooted tree is maximum level to any vertex of the tree. What is the maximum level to any vertex of tree? That is the height of the tree. For example, this is the root vertex, correct? A, root. Now, from root to this vertex, what is the level actually? What is the level? 1 and 2. So, here it is 2, correct? This is 1, this is 1, that is 2. 2 is the level, that one. Now, for example, if you are going, for example, I want to reach K. What is the level of that vertex actually? 1, then 2, then 3, correct? So, like that, check all the vertexes. Which one is the maximum level? That is we are calling height of that rooted tree. Okay. So, here height is 3. You can see level 3 is maximum. So, what is the height of that tree? The height of that tree equal to 3. Hope you understood that one. Clear? Maximum level, that is the height. Okay. All the vertex will be different levels. Out of this, which is the maximum number? That is the height of the tree. Now, next point we need to know. It is important point. Ancestor and descendant. What is the meaning of ancestor and what is the meaning of descendant word? Okay. Now, descendant of a vertex. For example, I am taking the vertex B. Okay. I am just considering the vertex B, for example. What is the meaning descendant of B means? Okay. Just to take the tree, subtree. See this tree. Okay. What are the vertex coming that one? All the vertex are descendants of that vertex B. Because what are the vertex going from B? For example, C. See, it is here. See, D also here. E also descendant with him. And F also, G also descendant, correct? So, what are the vertex down to that one? In that same branch, what are the vertex down to that one? That is calling the descendant. Okay, in the family tree also, you know what is the meaning descendant and ancestors. We are telling our descendant or ancestor like that. Same idea here. Okay, so that is the descendant. After that vertex, what are the vertices coming? That are the descendant in the same branch. Okay. Now, ancestor means, what is the meaning ancestor? For example, I want to consider the ancestor of this vertex. So, what you do is, starting from the root, just to take the path from to that vertex. What are the vertices coming in that path? That are called the ancestors of that vertex. For example, this vertex, this is the ancestor and this is the ancestor. Okay. Hope you understood that one. So, I can show one diagram here. For example, one tree here. Okay. I am just drawing a tree here. Okay. Okay, now I am giving some name here. This is vertex number 1, vertex number 2, vertex number 3, vertex number 4, vertex 5, vertex 6, vertex 7, vertex number 8 and vertex number 9. Okay. Now I want to ask the question, I want to answer the question, what are the ancestor and what are the descendant? Okay. For example, vertex V2. For example, vertex number V2. What are the descendant? First I want to write what are the descendant of the vertex V2. So what you do? After V2, what are the vertices coming? Take that, okay, in that branch only. So what are the vertices coming? V3, okay, and V4 and V5. These are the descendant of that one. V3, V4 and V5. Hope you understood that one. Now, what are the ancestors of that one? That is very important, okay. Ancestor of one vertex. For example, I want to take the ancestor of V8. Okay, V8 vertex ancestor. So what you do for that one, for finding ancestor? Just start from the root vertex. Okay, this is the root vertex. Just to draw a path from the root vertex to that vertex. Draw a path from the root vertex to that vertex. Now what are the vertex involved there? You can see V7 included. So V7 is an ancestor of V8 and V6 is an ancestor of V8 and V1 is the ancestor of V8. So ancestor of V8 means V7, V6 and V1. Okay, hope you understood. Ancestor of V8 and descendant of V2 is shown in this diagram. It is easy to understand that one. Clear? Okay. Now 11th point. What is the meaning subtree? Okay, subtree. So a subtree with V as its root is a subgraph of the tree consistent of its descendant and all edges incident to this descendant. For example, this tree, you can see this graph. A is the root vertex, okay, and you can see the tree here. What are the subtree? You can see, for example, B. Consider the vertex B. Okay, what is the subtree rooted at B? B rooted. What are the subtree? That means just to take that branch fully. See, this is the subtree, correct? For example, if you are root taking C, what are the subtree? This portion, full portion is the subtree, correct? So this one we can say left subtree, correct? And this is the right subtree. Okay, I just drawn here. For example, B rooted subtree I am drawn here. B, D, F, E, I, J. All the edges we need to draw. See, these all edges we need to draw in that one, and all the vertices. You can see these vertices. This is one subtree. Okay. Now same way, left subtree and right subtree also I am drawing here. You can see. This is the right subtree here. And for example, if I am taking the root as E, this one. What is the subtree root as E? Only you need to draw I, J and all the edges. So it is shown here. This is the subtree rooted at E. So whatever the root is given, from that what are the branches going? Every branches you can draw. That is the subtree connecting to the main tree. Hope you understood what is the meaning. Okay. Now I will ask one question here. You can see we need to answer this question. Example number 2. Consider a graph here. Consider a tree here. One tree is given. Okay, this is V0. Starting from V0, there are many branches you can see. V0, V1, V2, vertices you can see V1, V2, V3 up to V19 is there. Now what is the first question we need to answer? What is the level of the V8? V8, what is the level? Where is the V8 coming? This is V8, correct? So what is the level of this vertex? So what is the meaning level of a vertex actually? Started from the root vertex, just to draw a path up to that vertex. Path will be unique, only one path you can see. See, this is the path. So how many edges are involved in that path? 1, 2, 3, correct? Three edges are involved. So what is the level of the vertex V8? That is 3. Hope you understood that one. It is easy to construct. Just to construct a path, how many edges are involved in that path? That is the level of that vertex. Hope you understood that one. Now, B part of the question. What is the level of V0? Okay. What is the level of V0? What is V0 here? Just starting. Root vertex, correct? Root vertex means what is the level of root vertex? I told level is 0. Okay, 0th level. So root vertex always level will be 0 we are taking generally. Okay. Now, third question. What is the height of the rooted tree? Height of the rooted tree. Height of the rooted tree means what is the meaning? Maximum level. Maximum level each of the vertices. So you can see what is the maximum level here. For example, if you take this vertex, what is the level of this vertex? Start from the root vertex. 1, 2, 3. There are 3 edges involved. So this level is 3, correct? Maximum level is the height of the tree, correct? Now for example, if I am taking 18, this vertex. 18th vertex. So what is the level of that one? V0 to V2, 1, then 2, then 3, then 4, then 5. So here we are getting 5. So what is the maximum height, maximum level, that one? 5th level, correct? So the level of the height of that rooted tree is 5, maximum height. Okay, just to consider all the vertex. Out of all the vertex, which is the maximum level you are getting, that is the height of the rooted tree. Hope you understood that one. Now we will go to the next question, that is, what are the children of V10? V10, what are the children? V10, where we can see here, this is V10. What are the children of that V10? V14 is a children, V15 and V16. So what are the children of that one? V14, V15 and V16. Hope you understood that one. Okay, this is that idea. Now we will go to next question. What is the parent of V5? V5 vertex, what is the parent? This is V5 vertex. Who is the parent of that one? V1, correct? V1 is the parent of that one. So answer is V1. Easy question. Now we will go to next one. What are the siblings of V1? V1 sibling. Sibling means what? Same parent should be, correct? So V1 vertex, what are the sibling? So this one, V2 is the sibling, because V2 and V1 same parent, you can see, correct? So V1, who is the sibling? V2. So V2 is the sibling of V1. Hope you understood that one. Now next one, what are the descendant of V12? V12, what are the descendant? Descendant means to the down, correct? Same branch to the down. What are the vertices? So V12 means this one, correct? So V12 to down, what are the vertices? You can check it, that one. That are the descendant. So here one vertex V17, here one vertex V18, here one vertex V19. So what are the descendant? V17 and V18 and V19 are the descendant of the vertex V12. So hope you understood all these questions. Now again we are going to explain some more definitions, then we will come to the exercise after that. You can see binary tree. Now we are going another important idea, binary tree. What is the meaning of binary tree, correct? Binary number, when we are asking binary number, what are the binary numbers? 0 and 1. Binary means 2, correct? 2. So binary tree, what is the meaning binary tree? Actually binary tree means it is a rooted tree. Every internal vertex has at most 2 children, maximum 2 children only possible, every internal vertex. That type of tree we are calling binary tree. Maximum 2 children means what is the meaning? Okay, either one child, 0 child, or 1 child or 2 children. Okay, so this is the meaning binary tree. Either should have 0 child, there is no child, or 1 child or 2 child. That type of tree we are calling binary tree. For example, see this A vertex. How many children are there? There are 2 children, B and C. 2 is okay, maximum 2 children. Okay. Now for example B vertex, how many children are there? D and E, 2 children. For example D, how many child is there? Only 1, correct? 1 is okay, no problem. Now when we are going to the G vertex, is there any child for G? No problem, 0, correct? 0 child. So either it will be 0 child or 1 child or 2 child. That type of tree we are calling binary tree. For example C, how many children are there? C, only 1, no problem, correct? Now for example E, how many child are there? No, nothing, 0 child. So a binary tree with all the internal vertices, at most 2 children, or otherwise we can say in a tree, okay, in a tree each vertex either 0 child or 1 child or 2 children. This is we are calling the binary tree. Hope you understood that idea. Here you can see, okay, internal vertex at most 2, okay, including terminal vertex we can say like 0 child, 1 child or 2 child, like this. Okay, now again full binary tree, this is what more important, full binary tree. What is the meaning of full binary tree? Now full binary tree means it is a binary tree with each internal vertex has exactly 2 children. Okay, not 1 not possible, 2 children. All the parent should have 2 children, internal vertices having 2 children. For example A, okay, we have 2 children here. For example B, how many children? 2. For example E, how many children are there? 2. Like that. All internal vertex should have 2 children. Okay, otherwise what we can say, either we have 0 children or 2 children, one not possible. Okay, where 0 possible, actually the end vertex, terminal vertices, see terminal vertex F, there is no child, 0, correct? This also no, 0 child, this is also no, 0 child, this is also no, 0 child, correct? So terminal vertex 0 child, nothing, because it is terminal vertex. All other vertex, that is the internal vertex. What are the internal vertex here? Internal vertex means B is internal, E is internal, A is internal, correct? All these internal vertex, how many children will be there? 2. It should be 2 children will be there. So that one we are calling full binary tree. So you understood, I hope understood the difference between binary tree and full binary tree. Binary tree, there is a possibility of one child, internal vertex. But full binary tree, there is no possibility that one. All internal vertex should have 2 children. Okay, that is the idea here we are going. Okay, now there is one important rules are here connecting the full binary tree and binary tree. You can see what is that rule here. We need to know when we are doing questions this rule. If k is a positive integer and t is a full binary tree, if t is a full binary tree, then that binary tree, for example, k number of internal vertices, k number of internal vertices, okay, then that tree having total 2k plus 1 vertices and k plus 1 terminal vertices. Okay, k plus 1 terminal vertices. So I will tell you in short way. For example, if you are getting a full tree, full binary tree, okay, we have a full binary tree, for example. Okay, now what is telling that full binary tree? K internal vertices, for example. Okay, how many internal vertices are there? Internal vertices of a full binary tree is k, equal to k, for example 2, 3, 4, like that. Okay, so if a full binary tree having k internal vertices, then that full binary tree having how many number of vertices totally? Totally how many vertices? Total number of vertices equal to 2k plus 1. Okay, 2 multiply k number plus 1. How many terminal vertex will be there? Terminal vertex will be there in that tree should be k plus 1 terminal vertices. K plus 1 should be k plus 1 terminal vertex in a full binary tree. Okay, so in a full binary tree, if you know number of internal vertex, for example, I have internal vertex is 3. For example, I have internal vertex is 3. So that tree, how many vertices will be totally? Number of vertices totally 2k plus 1. So 2 multiply 3 plus 1. 6 plus 1, 7, totally 7 vertices will be there. How many terminal vertices will be there? Terminal vertices should be equal to k plus 1, that is 3 plus 1. How many will be there? 4 vertices, terminal vertices will be there. This is very, very important for drawing the full binary tree, this idea. Okay, so keep in your mind this idea. Now the second point, if t is a binary tree, not full binary tree, only binary tree. If t is a binary tree, then binary t with t terminal vertices. How many terminal vertices? T. And height of that binary t is h. Then always t number less than or equal to 2 times h, 2 power h. T less than or equal to 2 power h. So this point, what is the meaning actually? Binary tree. Okay, this is only possible for binary tree. What is the condition telling? Terminal vertices. Okay, number of terminal vertices, how many given? Equal to t, and height equal to h. Okay, if it is so, then what is telling? There is a relation connecting terminal vertex and height of the binary tree. What is the relation connecting terminal number of terminal vertices and height of the tree? T number of terminal vertices always less than or equal to 2 power height of the graph, 2 power h. This is the condition there. Okay, when we are doing questions in exercise, you can clear that one, t less than or equal to 2 power h. So keep in your mind this idea. Okay, now next point, maximum number of terminal vertices. Okay, maximum number of terminal vertices of a binary tree of height h is 2 power h. Okay, what is the maximum number of terminal vertices in a binary tree? 2 power h. Okay, so that point also multiple choice we can need to answer from this point. Maximum number of terminal vertices, okay, terminal vertices, maximum number of terminal vertices equal to 2 power h, where h is the height of that binary tree, only for binary tree, okay. So this point keep in your mind, very important point when we are doing questions. Okay, now let me do some examples here. See, explain why the graph with the given specification do not exist. This graph, this tree do not exist. Why? Explain why the graph with the given specification do not exist. First one, full binary tree with 9 vertices, 5 internal vertices. Is it possible or not with the full binary tree with 9 vertices and 5 internal vertices? I will show here. See, for example, our tree is full binary tree, correct? Full binary tree. How many vertices are there? 9 vertices, correct? Number of vertices equal to 9. And how many internal vertices? 5, correct? Internal vertex or internal vertices equal to 5. Is it possible or not? This is the question. What we studied, that is what we are using this rule. See, this rule. If T is a full binary tree means k internal vertices, total number of 2k plus 1 vertices and k plus 1 internal vertices. This point always, okay, keep in your mind for checking that one. So we will check here the idea, okay. What are the things given? You can see. Number of vertices is 9. Number of vertices equal to 9. Number of vertices means what is the rule actually in full binary tree? 2k plus 1. 2k plus 1 means equal to 9. It is given. Internal vertices equal to 5. Internal vertex means what is the rule actually? K number. So k number equal to 5. Internal vertex means k. So keep in your mind that two rules. What are the rules actually? Internal vertex. Internal vertex we are represented by k, and number of vertices, okay. Number of vertices we are representing by 2k plus 1, and terminal vertices, number of terminal vertices, okay. Terminal vertices we are representing by k plus 1, okay. This should be correct always in the full binary tree, okay. Now we will check here, is it correct or not here in this our question. Okay, so 2k plus 1 equal to 9, k equal to 5. Is it correct that one? Is it okay that one? 2k plus 1 we need to get to 9. K number is 5 is given. Internal vertices equal to 5, correct? So is it correct here? So just apply here 2k plus 1. 2 multiply, what is the k number? 5 plus 1. 2 multiply 5, 10. 10 plus 1, 11. Is it equal to 9? Is it correct? 11 equal to 9? No, it is not correct. Is it not possible? Correct? So it is not equal to 9. So is it possible to draw a tree like this one? Full binary tree with the 9 vertices and 5 internal vertices? Not possible. Okay? Not possible. So like this question, if you want to verify, we need to know this 3 cases. Internal vertices k means number of vertices equal to 2k plus 1 and number of terminal vertices equal to k plus 1. Hope you understood the first part of the question. Now B part, another condition. A binary tree, not full binary tree, sorry, it is full binary tree. I want to edit here. Okay, so binary tree height equal to 4. Height equal to, sorry, not it is binary tree, height equal to 4 and 18 terminal vertices. 18 terminal vertices. Is it possible or not? That is the question. Okay, a binary tree with height 4 and 18 terminal vertices. So we studied one rule. Maximum number of terminal vertices in a binary tree of height h. What was the rule we studied? 2 power h. Correct? That means 2 power, what is the height here? 4. So 2 power 4, 16. Correct? So maximum number of terminal vertices is 16 only possible. But how many is given here? 18. So it is not possible. So there is no binary tree with given properties, given specification. Hope you understood that one. Maximum number of terminal vertex should be 2 power h. We studied, you remember this rule. The maximum number of terminal vertices of a binary tree of height h is 2 power h. Correct? Should be like this one. So this question height is given. What is the height actually? height equal to 4. So 2 power 4. 2 power 4 means 16. But how much it is telling in the question? 18 terminal vertex. Is it possible? No. 16 only possible. So a graph with or tree with this specification, binary tree with this specification, not exist. Okay, now let me go to the next example. Example number 4. Draw a full binary tree with 7 vertices. Draw a full binary tree. Full binary tree means all the internal vertex should have 2 child, correct? So full binary tree with 7 vertices. How many vertices are there? 7. So I will show here, correct? Number of vertices equal to 7. Number of vertices equal to 7, here it is given. Number of vertices, what was the rule? 2k plus 1, correct? In full binary tree. So 2k plus 1 equal to 7. So 2k equal to 7 minus 1. 1 taking to next side. So 2k equal to 7 minus 1 means 6. So what will be k number? Both side divide by 2. That means 3. K equal to 3. K means what is the meaning? We studied just now, I told what is the meaning of k. K means internal vertex, correct? So number of internal vertex means number of internal vertex. How many we are getting? Equal to 3, because k equal to 3, correct? So total number of vertices 7, number of internal vertex we are getting 3. So we can calculate number of terminal vertices, correct? Number of terminal vertices. What is the rule actually? Number of terminal vertices? K plus 1, correct? So k plus 1 means 3 plus 1, that is 4. So how many terminal vertices are there? 4. So in this graph we have 3 internal vertex, 4 terminal vertex, totally 7 vertex. 3 plus 4, that is 7 vertex. So now we can draw the graph. How we are drawing the graph in this case? Okay, some number of internal vertex 3, number of terminal vertex equal to 4. So I can draw here. First I am drawing the internal vertex here. See, these 3 are the internal vertex, for example. Okay, internal vertex means what we need to do? Full binary tree here. So each vertex having 2 children. So here 2 children. This vertex also should have 2 children. This also should have 2 children. See, 2 children here. This also 2 children. So you can see how many internal vertex are there and how many terminal vertices are there. Correct or not, you can check it. This is one internal vertex, V1, correct? V2 also internal vertex. V3 also internal vertex. Now what are the terminal vertex there? You can see the terminal vertex. Terminal vertex means there is no child, correct, in that vertex. So V4 is terminal, V5 is terminal, V6 is terminal, and V7 is terminal, correct? So totally we have 7 vertex, it is correct. How many internal vertex? 3, it is also correct. How many terminal vertex? 4, that also correct. So this is the tree representing that question. Hope you understood that one. You can see the ideas here, the drawing graph. Now next one, example number 5. Draw a full binary tree. Again we need to draw a full binary tree. That means each internal vertex should have 2 children. Okay, with height 3. Height should be 3, and having 7 terminal vertices. 7 terminal vertices. Okay, height equal to 3, 7 terminal vertices. Okay, so height is 3 given in the question. How many terminal vertices? Terminal vertices equal to 3. What is the rule for the terminal vertices? We are studied k plus 1. So k plus 1 equal to how much? 7. Correct? Terminal vertices equal to 7 means k plus 1 equal to 7. From that k we are getting k equal to how much? 6. So 6k equal to 6 means k means what is the meaning? Internal vertex. So 6 internal vertex. Okay, internal vertex equal to 6. Okay, terminal vertex number means equal to 7. Height, how much we are getting? Height equal to 3. Maximum height equal to 3. So we need to draw the graph here. So you can see the graph is there. So first we are drawing the internal vertex. This is first internal, second internal, third internal vertex. Okay, internal vertex we are doing. Then 6 internal vertex we have. 3, then 4, then 5, then 6. See, 6 internal vertex I drawn. Now each internal vertex we need to put how many children? 2 children, correct? So this one having 2 children, this one having 2 children, here we have 2 children, this also 2 children, and here also 2 children. Okay, hope you understood. And this also 2 children. All the internal vertex should have 2 children. Now you can check it how many terminal vertex are there. Okay, so now I will mark here how many terminal vertex we have. Here one terminal, there is no child here, here no child, here no child, here no child. So how many terminal vertices are there? 1, 2, 3, 4, 5, 6, 7. So internal vertex 6 correct, terminal vertex 7 correct, height is 3, height 3 should be, is it correct or not? Height is 3, yes it is correct, because if you start with the root, what is the maximum level? You can see 1, 2, 3, maximum 3 only coming, so height also equal to 3. So that is the full binary tree representing that specification. Hope you understood that question. Okay, now let me go to some small applications of the tree. Representation of algebraic expression by using binary tree. Okay, just some small examples only we are discussing here. Representation of algebraic expression. Algebraic expression means, what is the meaning? Like a plus b, or a divide b, or a multiply b, like this. Okay, algebraic expressions representing by a binary tree. So binary trees are specially used in computer science to represent algebraic expressions with arbitrary nesting balanced parentheses. Parenthesis means the bracket. Okay, for example, a divide c plus d, c plus d. C plus d is the bracketed term, nested term, correct? So which one we will draw first in the tree? Okay, how we are representing this one? These algebraic expressions we can represent by the binary tree. We have some examples here. You can see, for example, a divide b. We need to represent by a divide b. So what you do is, left child we represent by a, right child we represent by b. Okay, the root vertex we represent by d, divide. Okay, so we need to read like left to right. Left to right we are reading. How we are reading then? A, then divide, then b. A divide b. Okay, left to right we are reading. So a divide b. So like that we can represent the algebraic expressions by using binary trees. Okay, now for example, a divide c plus d. We need to answer this one. A divide c plus d. So first this parenthesis term, this bracketed term c plus d. So you can see c here and d here and here plus. Okay, so c plus d, that is in the bracket. Now what is the next one? A divide. So one another vertex here, a, root vertex we are taking divide. A divide c plus d. We need to read like left to right. So a divide c plus d we are representing like this one. Now another one, you can see another example. A divide b minus c multiply d. Correct? C multiply d. So first we need to do this one, c multiply d. You can see here c and d, here it is multiply, dot means multiply. So c multiply d first. After that b minus. So you can see b here and minus here. So b minus we are represented. After that a divide. So a here and divide here. So a divide b minus c plus d. We can represent by using a binary tree like this one. Hope you understood that one. This is a simple application in the computer representation. Okay, next one. Now we are going to do the exercise questions. Before going to do the exercise question, you can see the summary, whatever we discussed now briefly. That summary you can see here. What are the main ideas actually? A tree with n vertices, how many edges will be there? N minus 1 edges. A tree with n vertices should have n minus 1 edges. Now what is the next point? In a full binary tree, k means number of internal vertices, then 2k plus 1 vertices should be there and k plus 1 terminal vertices should be there. Now a T is a binary tree. Okay, if T is a binary tree, with T terminal vertices, T number of terminal vertices and height h means, what is the relation connecting the terminal vertices and height of the binary tree? T less than or equal to 2 power h always. T number of terminal vertices less than or equal to 2 power height of the tree, binary tree. Now The fourth point is very important. Maximum number of terminal vertices. Maximum number of terminal vertices in a binary tree is, what is the rule actually? 2 power h. So this is the summary of this section. Now we will go to the questions one by one. First question. Okay. Which of the following graphs are tree? Now we are answering one by one. Which of the following graphs are representing trees? The first graph now, A part. So what we need to know, that one tree or not? In the beginning we discussed what is we need to check actually if it is tree or not. What we need to, first we need to check, is it connected or not? Okay, connected or not. Secondly, we need to check there should not have any symbol circuit, correct? Symbol circuit. And also, you know, loop, parallel edge, this should not be there. Loop and parallel edge should not be there. So this is the main condition, connected and no symbol circuit. So first one, you can see this one. Here there is no circuit, symbol circuit, correct? It is all connected. Each vertex is connected with the other, correct? There is a path between each of the vertexes. And there is no circuit also, symbol circuit also. Circuit means like this one. It is not there, correct? So that graph is a tree. Yes, we can write it is a tree. Why it is a tree? Because it is connected and no symbol circuit. Okay, connected and no symbol circuit. So we need to write the reason like it is connected and no symbol circuit. No symbol circuit. Hope you understood that question. Now B part. Is it B represent a tree? B question? No. Why it is not a tree? Because it is not connected. See, there is a branch here. There is another branch here. There is no connection between these two branches. This vertex and this vertex, there is no connection here. Correct? So it is not a tree. It is not represent a tree because what is the reason? It is not connected. Hope you understood the second part. Okay, now we will come to the third part of the question. This one, C part. What about C part? Is it a tree representing? Yes, it is a tree. It is connected and there is no symbol circuit. See, when we are seeing the graph, it will confuse. See, this is vertex, this is another vertex. Here there is no vertex. Okay, so there is no circuit there, symbol circuit. So each vertex are connected. So it is a tree because it is connected and no symbol circuit. Okay, there is no symbol circuit. Now what about D? D is not a tree. Why it is not a tree? Because there is a symbol circuit. You can see, for example, starting from here, going here, coming again to the same vertex. There is a like a triangle. There is a symbol circuit. So it is not a tree because there is a symbol circuit. Hope you understood. Now E graph. What about E? Yes, it is tree, correct? It is connected and there is no symbol circuit. What about F? F it is a tree, correct? Because there is no symbol circuit. See, you can see when we are seeing this vertex and this vertex is connected. There is no vertex here and here. Okay, so it is connected and there is no symbol circuit also. So this is F representing, sorry, not F representing is not a tree, sorry. That we can see not a tree. We can say it is not a tree. Why it is not a tree? Because you can see starting from here, it is going here, going here, going here, going here, going here, and again coming to the same point. It is like a symbol circuit, correct? So it is not a tree. We have a symbol circuit there. So it is not a tree here. Now question number G. You can go. I hope you understood that question. Question number G now. Is it a tree or not, that one? Question number G. When we are seeing, it seems like a tree. But is it a tree, that one? We can see that one. See that graph, you can see. The graph is drawn like this. Right? Here one vertex, here one vertex, here one vertex, here one vertex. Correct? Here also one vertex. But is it a tree? Is it connected, that graph? See, when we are drawing that separately, there is one branch like this, correct? Another one branch like this one. But this branch and this branch, there is no connection. Especially, for example, this vertex and this vertex, there is no connection. It is not connected. This and this not connected. That means this and this not connected, correct? You cannot see any connection that one. So that represent not a tree, because it is not connected. Hope you understood. Now what about H graph? Is it represent a tree or not? Yes, it is a tree, correct? It is a tree. There is no symbol circuit and it is connected also. All the edges are vertices are connected, and here there is no vertex. Keep in your mind, okay? There is no vertex there, so it is connected, and there is no symbol circuit also. So that is representing a tree. Hope you understood how we are checking tree or not. Okay, now let me go to the question number 2. You can see question number 2. Answer the following question about the rooted tree. Illustrated here. Which vertex is the root? You can see the graph on this side, tree on this side. Which vertex is the root? Okay, you can say answer easily. This is the vertex root A. So which vertex is the root? First question answer, A is the root. Okay, which vertex are the internal vertex? Internal vertex means, what is the meaning? Internal vertex means vertex should have child, correct? So for example, this one is internal because this having child. A is internal vertex, it having child. D is internal because this is having children's. C also internal, children's are there. H also internal, children's are there. F also internal vertex, there is having children's. Q is internal vertex. J is internal vertex. T is also internal vertex. Okay, all the vertex with having children's, that is calling internal vertex. So we can write the answer A, B, C, D, F, H, J, Q and T. These are the internal vertex. Hope you understood that one. Now we will go to the next one. The next question. Everything we can draw the graph there and study that ideas. Now C part, which vertices are leaves? Which are the leaves? Leaves means, what is the meaning? Any vertex, no children, that is leaf. For example, E, it is leaf, there is no children for E. L, M, N, there is no children's. G, O, P, I, K, R, S and U. These are the leaf vertices, correct? So we can write the answer here. E, G, I, K, L, M, N, O, P, R, S, U. These are the leaves are there. Leaves means terminal vertex. Keep in your mind, leaves or terminal vertex. Okay, these are the leaves or the terminal vertices. Okay, now next question. Which vertices are the children of J? Okay, which vertices are the children of J? Correct. So J, you can see that J here. Yeah, this one. Okay, which vertices are the children of J? What are the children of J? Q and R. Okay, Q and R are the children of the vertex J. So we can say Q and R are the children of the vertex J. Hope you understood. Now next one we can go to E. Question number E. What is question number E? Which vertex is a parent of H? Parent of H vertex. H is this one. Who is the parent of that one? C. Correct. C is the parent of H. Hope you understood. So we can mark here parent of H means we can get it C. Now what is the next question? Which vertices are siblings of O? Siblings of the O vertex. O means this one. Who are the siblings of that O vertex? Sibling means they should have same parent. So P is the sibling, correct? Because P and O same parent. Okay, so O sibling is P. Okay, hope you understood. So I can mark here sibling of O means P. P is the sibling of O. Now next one. Which vertices are ancestors of M? Okay, important part. Ancestors of M. Which vertices is the vertices are the ancestors of M. So M is this vertex, correct? So what we do for finding ancestors? Starting from the root, okay, this is the root vertex, just to draw the path. So here is the path, here is the path, correct? So what are the vertices involved in that path? What are the vertices involved in that path? That are the ancestors of that vertex. So what are the vertices involved? F is there, B is there, and A is there. Okay, so F, B and A are the ancestors of the vertices vertex M. So we can write F, B and A are the ancestor of the vertex M. Hope you understood. Now the next one, next part of the question. Which vertices are the descendant of the B? Descendant of B vertex. So B, descendant. Descendant means the down vertex, same branch down vertices. So what are the descendant of B? E is the descendant, F is the descendant, L is the descendant, M is the descendant, and N is the descendant. Same branch, that branch you can consider what are the vertices involved there, that are the descendant of B. So we can write the answer. What are the descendant? E, F, L, M and N. Hope you understood this question. All the ideas are there in this question, in that graph. Okay, so you can understood easily. Okay, it is natural example. Okay, like whatever we are doing, usually we are telling the words. Okay, internally, root, parent, sibling, ancestor, descendant. These are usually you are using words. So easily you can understood that one. Okay, now next one. The same graph. We need to answer some more question. Answer the following question about the rooted tree. What is the level of each vertex given in the rooted tree? Okay. What is the level of each vertex given in the rooted tree? For example, A. What is the level of A? Level 0. Correct. Now B, C and D. What is the level? 1. Because only one edge distance. Correct. Only one edge in that path, so level is 1. So like that all the edges, vertices, what are the level of each vertex is the question. So I am already shown here, you can see what are the, for example, A, level number 0, level B, C, D, B, C, D vertex level 1, E, F, G, H, I, J, K level 2, L, M, N, O, P, Q, R level 3, S, T level 4, U level 5, maximum level is 5, correct? Maximum level is 5. That means the height of the tree is 5. Maximum level is the height. Okay, height of the tree. Keep in your mind. But it is asked only the level. But you can see what is the height of the tree. Okay. So this is level 0. This is level 1. This is level 2. Level 3. Level 4. Level 5. Like this. Okay. So we can calculate each vertex level. For example, if it is asking N. What is the level of N? So what you will do? Starting from the root. Okay. Starting from the root, just to draw the path. How many edges involved you can check it? 1, 2, 3. So 3 is the level of that vertex. Correct? 3 is the level of that vertex. Like that every vertex level we can calculate that one. Okay. Now next question. Draw the subtree that is rooted at A. Draw the subtree rooted at A. Starting from A, what is the subtree? So you can check where is A. A means the root, main root. So what is the subtree? Starting from A means the full graph. See this branch and this branch, every branch we need to draw the full tree. So every tree is subtree of itself. Okay. So rooted at A means this is the main root. Full tree we need to draw. So the subtree rooted at A means in this graph it is full tree. Okay, so the answer will be like this. The full tree we need to draw here in the B part. Now we will go to C part now. What is C part? Draw the subtree. We need to draw the subtree that is rooted at C. C root. So where is the C? You can check it. C is here. Correct? So only take that branch. C root coming branch we need to take. That is the subtree. Okay, rooted at C. So C will be there, G will be there, H will be there, O will be there and P will be there and all edges connected that one. So you can see that graph here, C, G, H, O and P, all the edges connected that vertex also will involve there. So this is the subtree rooted at C. Now question number D. Draw the subtree that is rooted at E. E vertex rooted. So you can check the graph now. What is the subtree rooted at E? Where is E? E is here. So anything is there, only that edge, or only that vertex, only that vertex, that is the subtree that is rooted at E vertex, vertex, okay, only E. So we can draw the graph only E like this, okay. Hope you understood. That is the trivial tree. Trivial tree means only one vertex, we studied before, trivial tree, okay. Trivial tree, only one vertex will be there. Hope you understood that question, how to do these things, subtrees calculation, drawing, okay. Now question number 4 here now. Question number 4. So let me go to question 4. What is question 4? Draw a graph. Draw a graph with given specification. Some specification will given. Draw a graph. Or explain why no such graph exists. If we cannot draw, just tell why no that graph not exist. That is the question. So what is the first question here? Full binary tree. We need to draw a full binary tree, 5 internal vertices. We need to draw a full binary tree with 5 internal vertices. Okay, full binary tree means, what is the meaning? Each vertex should have 2 children, correct? Internal vertex should have 2 children. Okay, 5 internal vertex. Internal vertex, how we are representing internal vertex? K, correct? So internal vertex K equal to how much given? 5. Okay. Now if you want to draw a binary tree, full binary tree especially, you need to know how many internal vertex. Okay, how many internal vertex and how many terminal vertex. How many terminal vertex. This if you know, only we can draw the graph. Okay. So trees, I mean full binary tree. If you want to draw, we need to know how many internal vertex, how many terminal vertex. Okay, if you know these two, you can check it how many total vertex also. How many total vertex. So these 3 points always careful when we are drawing a full binary tree. For example, here in this question, full binary tree with internal vertex, that means K number is given. K number equal to 5. Now we need to calculate how many terminal vertex. What is the rule for the terminal vertex? Terminal vertex means K plus 1, correct? So how many will be there? 5 plus 1, that is 6, correct? Total number of vertices. Total number of vertices means 2k plus 1, correct? 2k plus 1 means 2 multiply k number is 5 plus 1, so that 11. You can add these two number also, that is also fine. Here we are getting 5, here we are getting 6, so 5 plus 6 also 11. So always when we need to draw the full binary tree, find these 3 numbers. Now we need to draw the graph. Okay, we need to draw the full binary tree here. So how many internal vertices are there? 5. So we are starting with 5 internal vertices. Okay, I can draw here. So one vertex, vertex number 1, vertex number 2, vertex number 3, vertex number 4, vertex number 5. So 5 internal vertex. Okay, I am highlighted with blue color, internal vertices. Now we are drawing the tree here. V1, V2, full binary tree. Full binary tree means each vertex should have 2 children. Okay, so this one 2 children, finished. Now this one I am drawing 2 children, finished now. Okay, now this one also we need 2 children, finished here. Terminal vertex I am highlighting with red color. Now this one with 2 children, one here, done now. Now this also with 2 children, so here and here, correct? 2 children each, full binary tree. Now you can check how many internal vertex is there. Internal vertex 5, correct? How many terminal vertex are there? You can check it now. See, terminal vertex now, this is V6, V7, V8, V9, V10, V11. Totally 11 vertex, correct? So you can see is it correct or not. Yeah, totally 11 vertex, internal vertex 5. So automatically terminal vertex will be 6. Correct? Terminal vertex should be 6. You can see 1, 2, 3, 4, 5 and 6. 6 internal vertex, terminal vertex. So this is the tree, full binary tree representing that specification. Hope you understood. Full binary tree with 5 internal vertices we can represent like this one. Okay, now let me go to the next one, 4b. What is 4b? Draw the graph. Full binary tree, 5 internal vertex, 7 terminal vertex. Okay, if possible draw, if not possible tell what is the reason. Okay, so full binary tree, 5 internal vertex. Internal vertex means which letter? K. K equal to 5. Correct? K equal to 5. So I am writing in detail here. Internal vertex. Number of internal vertex means K equal to 5. So how many terminal vertex will be there? Terminal vertex number equals K plus 1. Correct? K plus 1 means how many? 5 plus 1. That means 6. Okay, but how many is given here? 7. Is it possible 7? No, this is wrong. Only 6 possible. Correct? So K plus 1 should be 6, not 7. See here 7 terminal vertex are given. It is not possible. So we can write it is against the rule. So not possible to draw the graph. Okay, it is not possible to draw the graph because terminal vertex should be 6, not 7. Okay, 7 not possible. So there will not be any full binary tree in this specification. Hope you understood that question. Okay, now we have many questions here. We can answer one by one. Full binary tree, question number C first. Full binary tree with 7 vertices and 4 internal vertices. 7 vertices and 4 internal vertices. Is it possible or not? So we will see how many vertices are there. Number of vertices equal to 7. Number of vertices, what is the rule actually? 2k plus 1. 2k plus 1 equal to 7. So check what is the k value. 2k equal to plus 1 take to next side. So 7 minus 1. So 2k equal to 7 minus 1 means 6. Divide both side by 2. So what will be k value? That is 3. Correct? K equal to 3 we are getting. What is the meaning k actually? Internal vertices. Correct? Number of internal vertices equal to 3. Correct? But how many given here in our question? Internal vertices 4 is given. Is it possible 4? No, it is not possible. That means this is wrong. 4 internal vertices not possible. How many internal vertices only possible? 3. So it is 3. It should not be 4. So there is no tree. No full binary tree. There is no full binary tree representing that specification. Hope you understood that question. Okay, question number C, 4C part of this one. Okay, now we will go to question number 4D. Full binary tree with 12 vertices, possible or not? Full binary tree, it should be full binary tree with 12 vertices. 12 vertices, possible or not? This is question number 4D part. Okay, so we will check that one. Full binary tree with 12 vertices, possible or not? 12 vertices, number of vertices equal to how much given? 12. What is the rule for total number of vertices? 2k plus 1. So 2k plus 1 is 12. Just calculate what is the k number. 2k equal to 12 minus 1. Correct? Plus 1 take to next side. So 2k equal to 12 minus 1 means 11. So what will be k actually? 11 divided by 2. What is that number? 5.5. Is it possible like that? 5.5? K means what is the meaning actually? Internal vertex. Correct? Internal vertices. Is it possible 5.5 vertices? Not possible. Correct? It should not be 5.5. It should be an integer number. 6, 7 like that. 5.5. There is no half vertex like that. Okay, so there is no full binary tree. There is no full binary tree representing this specification. Okay, now next question we will go. Question number 4E part. Full binary tree with 9 vertices. Question number 4E. Full binary tree with 9 vertices. Question number 4E part. It should be full binary tree with 9 vertices. Correct? Okay. So 9 vertices means 2k plus 1 equal to how much? 9. Correct? So 2k equal to 9 minus 1. So 2k equal to 8. 9 minus 1 is 8. So k will be what? 4. Correct? So k equal to 4. K means what is the meaning? Number of internal vertices. K means number of internal vertices equal to 4. So we got the number internal vertices 4. Total vertices how many? 9. So as I told you, always we need to check how many internal vertex, that is 4. How many external vertex, that means terminal vertex leaves. Okay, how many terminal vertex will be there? How many total number of vertices? Total number 9. Internal is 4. Correct? So terminal vertices, how many it will be there? 5. Because k plus 1. Terminal vertex means k plus 1. K is 4. 4 plus 1, that is 5. Now we will draw the graph. Is it possible, or we need to check that one? Internally we need 4 vertices. So I can show here the graph. Internally it should have 4 vertices. So 1 here, this is the root vertex. Second, V1, V2. So V3 here. Now one more we need to draw, V4. Okay, so V4 here. Full binary tree we need to draw. So all the vertex should have 2 children. Okay, this 2, this vertex also 2. Okay, and this also we have 2. This also we have 2. So here the terminal vertex, terminal vertex, terminal vertex. Now we can mark, this is V5, V6, V7, V8 and V9. 9 vertices totally. Correct? So the graph is correct. Totally we have 9 vertices, 4 internal and 5 terminal vertices are there. Correct? So this is the graph. This is the tree representing that specification. Full binary tree representing that specification. Hope you understood that one. Now the next one we will do. Now question number F. Question number F. Binary tree, height 3 and 7 terminal vertices. A binary tree with height 3 and 7 terminal vertices should be there. Is it possible or not? Okay, binary tree. In our mind, binary tree. So we can go now this one. Binary tree with height equal to 3, terminal vertex equal to 7. Now in a binary tree we studied one rule, the relation connecting terminal vertex and height. What was that rule we studied in the binary tree? In the binary tree there we say relation connecting height and terminal. What is that one? T less than or equal to 2 power h. Is it correct or not? First we need to check. Like a graph, like a tree exists or not, first we need to check. What is the T number? Number of terminal vertices? 7. Less than or equal to 2 power. What is the height of the tree? That is 3. So 7 less than or equal to 2 power 3 means 8. Correct? So 7 less than or equal to 8. Is it correct or not? Yes, it is correct. 8 is the bigger number, 7 is the small number. So it is true. Correct? So we need to draw a graph with the same specification. Terminal vertex equal to 7. Correct? Terminal vertex equal to 7. There are 7 terminal vertex. So automatically how many internal vertex will be there? Internal vertex means it should be 6, correct? It should be 6 vertex will be there, because we can use the rule k plus 1, that rule k minus 1 will be there. Internal k means terminal is k plus 1. So 6 and 7. So now I am drawing the graph here. I can draw the graph here. So there are 6 internal vertex. This is question number 4 F part. Okay. There are 6 internal vertex are there. 1, 2. We can go 1, 2 and 3, 4, maybe one more here 5 and one more here 6. Okay, I am just drawing here the tree like this. Can draw like this. Okay, like this. Okay, so we will get the graph here. You can check how many vertices. Vertex 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, 11, 12 and 13, correct? So 6 plus 7, totally 13 vertex will be there. So we got 13 vertex and we are getting a binary tree representing that specification. Hope you understood that one. Now question number G. Question number G here. We need to draw a full binary tree, height 3 and 6 internal vertex. Height is 3 and 6 internal vertex. Okay, so we need to draw this graph. This graph is already same as number A here. Number A, whatever we did before, the same as this one. Okay, so anyway, you can see this one. Full binary tree, height 3, height equal to 3, h equal to 3, and 6 terminal vertices, correct? 6 terminal vertex equal to 6. What is the rule for the terminal vertex in full binary tree? Full binary tree. We know what is the rule for the terminal vertices. K plus 1. K plus 1 equal to 6. So what will be k number? 1 take to next side. 6 minus 1. So k equal to 5. K means what is the meaning? Internal, correct? Internal vertex equal to 5. So we got the number here already. Number of internal vertex 5. Number of terminal vertex 6. Totally how many vertex will be there? 11. Correct? So we need to draw a graph representing the specification. Internal vertex 5. So 1 here, 2 here, 3, 4 and 5. Full binary tree. So each vertex having 2 children. We can draw each vertex should have 2 children like this. Now you can mark the terminal vertices, leaves like this. So you can check how many totally vertex, how many? V1, V2, V3, V4, okay, V5, V6, V7, V8, V9, V10 and V11. Totally 11 vertex are there. So this is the graph representing that specification. Hope you understood this question. Now question number H. Binary tree, height 3, 9 terminal vertices. A binary tree with height 3 and 9 terminal vertices. So height equal to 3. Number of terminal vertices equal to 9. Binary tree, that is important point, not full binary tree. Binary tree with height 3 and terminal vertex equal to 9. So we studied one rule connecting the height and terminal vertex in binary tree. What was that rule? T less than or equal to 2 power h. First we need to check is it correct or not. If it is correct only, we can draw the tree. Okay, so we will check here. What is the t number? 9. Less than or equal to 2 power. What is the h number? 3. Correct? That means 9 less than or equal to 2 power 3 means 8. Is it correct or not? 9 less than or equal to 8? It is not correct, because 9 is the bigger number, not 8. Correct? So this equality is not, inequality is not correct. See here, greater portion is 8 number, but 9 is the bigger number. So what answer we can write? Not possible. Correct? There is no binary tree with that specific conditions. Okay? So that is the question number 4H. So I hope you understood all the ideas from this section, 4.4 section. Okay, what are the things we are studied and related questions. Now we will practice one practice test is here. One question, some multiple choice questions I am doing here. You can see what are the question. For example, first question, practice test, first question. Given graph is a binary tree or not? Given graph is a binary tree or not? What we are checking for binary tree actually? Binary tree means each vertex either degree 2 or 0 or 1. Okay, 0 child, sorry, not degree, either 0 child or 1 child or 2 child. That is the meaning binary tree. Full binary tree means all internal vertex should have two children. Okay, so keep in our mind that one. Binary. Binary means what is the possibility? Either 0 child or 1 child or 2 children. This is the meaning binary tree. Okay, full binary tree means the difference is there. Full binary. Full binary means what is the condition? Either 0 child or 2 children. Okay, so is it correct or not? You can see this vertex, there are 2 children, no problem. This vertex, 2 children, no problem. This vertex, 2 children, no problem. This vertex, 0 children, 0, 0, 0 child, correct? So this is a binary tree. So we can write, yes, it is representing a binary tree. Okay, 0 child or 1 child or 2 child. This is the condition. Okay, let me go to the second question. The given graph become a tree if which edge removed? This is not a tree now. Which edge if you removing should be a graph? That is asking the question. So in a tree, correct? In a tree, it should not have symbol circuit, correct? No symbol circuit. So anywhere circuit is coming, one edge remove, so that we will get a tree. Okay, so which edge we can remove? E5, can we remove E5? E5 means this one, we cannot remove this one, correct? So it will not be connected if you are removing. If you are removing this, 4 vertex will be alone, so it will not be connected. E2 can we remove? No. E2 remove means it again, this will be separate, this will be separate, it will not be connected, so that also not correct. So which edge we need to remove for getting a tree? This edge, because this is creating a symbol circuit there. For example, see, starting 1, 0, 2, 1, see, a circuit is there. So one of the edge E4 we need to remove there, then only that become a tree. So E4 edge we need to remove. So E4 is the correct answer. Hope you understood that one. Remove the symbol circuit. Okay, remove symbol circuit edge coming in that one. Okay, now next question, question number 3. What are the question? Tree height. What is the height of the tree? Height of the tree means maximum level, correct? So what is the maximum level? You can see what is the maximum level? 1, 2, 3, correct? Here 3. Now is there any other more than 3? You can check it. Here 1, 2, 3. So 3 is the maximum level. Okay, so we can write maximum level equal to 3. That is the height of the tree. Now next question, question number 2 here. Level of first node. One node, what is the level? 1 means it is this node. What is the level of this node? 0. 0 level, correct? Because this is a root node. Root node always level will be 0. Now what is the next one? Parent of node 8. 8 is node this one. Who is the parent of that one? 4. Now next one, childs of node 5. Node 5 child. So this is node 5. So who are all the child? 9 and 10. 9, comma 10. Now what is the next question? Leaf nodes. What are the leaf node? Leaf node means there is no child. 9, 10, 6, 3, 11, 12 and 8. These are the leaf nodes. Okay. So we can write 9, 10, 6, 3, 8, 11 and 12. Leaf nodes. There is no child. Correct. That node is called a leaf node or terminal vertex. Sibling of 6. 6 is this one. Who is the sibling of this one? This is the sibling. 5. Correct. Because both are having same parent. So 5. You can write 5 is the sibling of 6. Now what is next one? Ancestor of node 10. 10 is this one. So what is the ancestor of this one? Ancestor means starting from root vertex, draw a path like this, like this, like this. What are the vertex coming in that path? That is the answer. So what are the vertex? 5, 2 and 1 including the root. Okay. So 5, 2 and 1. That are the ancestors of the vertex 10. Now what is the next one? Descendants of the node 4. Node 4 is here. What are the descendant? This node. So just to take this sub tree, this one. What are the vertex coming? 7 is coming, 8 is coming, 11 is coming and 12 is coming. So what are the descended down to that one? Correct. So 7, 8, 11 and 12. Now what is the next question we need to answer? Maximum, write that one. Maximum length of the tree starting from vertex 1. Maximum, we need to write maximum length of the tree starting from 1. Starting from 1, maximum length. So we can write this is the 1, correct? Maximum length of the tree starting from 1. So we can write what is the maximum length? This 1, 2, 3, correct? Maximum length, 3 maximum coming. See here, this one. Maximum length of the tree starting from the root vertex, that means the vertex 1, you can see that is 3. 3 is the maximum. I hope you understood this question also, how to calculate the maximum length. Okay, now next one you can add here. How many vertices? How many vertices are there in the tree of 12 edges? How many vertices? Number of vertices, n means vertices. Okay, I will write here vertices equal to n means how many edges will be there in the tree? N minus 1. Correct. We studied a tree with n vertices has n minus 1 edges. Correct. Now here what is given? Here it is given like how many vertices? How many vertices is the question? N equal to how much? There are 12 edges. So edge number is 12. So n minus 1 equal to 12. Okay. So what will be n value? N equal to minus 1 take to next side, 12 plus 1, that is 13. So what is the correct answer? Is 13. Okay. Now fifth question. The maximum number of terminal vertices. The maximum number of terminal vertices of a binary tree of height h is that. We studied one rule actually. Maximum number of terminal vertices of a binary tree of height h is 2 power h. Correct? Maximum number of terminal vertices. Maximum number of vertices of terminal vertices equal to 2 power h. H means the height of the tree. Okay, what is the height here? 4. So what will be the answer? 2 power 4. What is 2 power 4 actually? 16. Correct? So what is the answer correctly? It is equal to 16. I hope you understood that one. Okay, I hope you understood what is the meaning of this questions, 5 questions. So all the ideas we discussed here, you can practice by using some graphs. Yeah, thank you very much for watching this recorded class. Please subscribe my channel for getting more recorded classes. Thank you very much.